Hello, in today's video, we're going to be talking about idle air control valves, how they work, the symptoms you may experience when an idle air control valve isn't working properly, and how to test them to make sure that they need to be replaced. The way they work, as the name implies, is that they help control your vehicle's idle and RPMs by regulating the amount of airflow when your vehicle is running at idle. Under normal conditions, there are two ways that the engine will get airflow. One is through the throttle body's butterfly valve, but on these mechanical throttle bodies, this remains closed when your foot is off the pedal. So being that it needs airflow at idle too, it'll need a second entrance to get that airflow. So that's where this idle air control valve comes into play. On throttle bodies like this one, where an idle air control valve is mounted to them, they'll have a hole somewhere on the inside of the throttle body, bypassing the throttle plate, allowing airflow into this idle air control valve, which can be seen here on this Toyota throttle body, and located here on this GM throttle body. This opening allows air into this port, and this valve will regulate the amount of air that it allows through. Then this air comes out the exit port and behind the throttle body's butterfly valve. In the mornings or when you first start your car, the computer will have the injectors inject extra fuel to start and keep your engine running till it warms up. So to keep up with the extra fuel, these idle air control valves will open up, allowing extra air. So once the engine warms up, the valve will begin closing up the port, allowing less air through. At the same time, the engine will reduce the amount of fuel being injected into the cylinders, and that's when your vehicle's RPMs drop and the idle smooths out. But when you have an improper functioning idle air control valve, it may end up getting stuck in a certain position, like this one, which was stuck open. The idle would begin surging once the truck would warm up, being that the computer adjusted the amount of fuel being injected, but the valve didn't close, so it continued getting the same amount of air, which was too much airflow for the amount of fuel it was getting. Most idle air control valves like these two are electronically controlled by your vehicle's computer, telling it when to open or close. But in this valve's case, it's solely controlled by coolant flow. As the coolant circulates around this valve, like a thermostat, it'll have a wax pellet that'll heat up and begin to melt the wax. As it melts, it'll push out on this pin, which pushes out on this plunger, allowing less and less airflow through the more it heats up. But as with anything, it can also fail, where say the valve gets stuck, the spring breaks, the pin gets stuck and won't move, any number of things. Or as in this case, this valve quit working because the coolant passage got plugged up. As you can see in there, all that gunk kept the coolant from circulating through this valve. Being that this valve on this model relies on coolant for heating it just wouldn't heat up enough to function properly. On these type, the coolant level also plays a huge role in how well they work, so you always want to check your coolant level first. So how's the function differ on these that are electronically controlled? Well, they're fairly similar, except that this valve does not rely on the coolant flowing around this valve to open it or close it. Although it still has coolant circulation, this is only to keep this valve from sticking in really cold weather. And instead, the computer controls this valve electronically, rotating it open or closed based on the amount of fuel it's injecting into the engine and the coolant temperature sensor to let it know when the engine is up to temperature. This plunger type valve also expands or retracts on the computer signal to open or close this valve, controlling the airflow through this port and out the back of the throttle body into the intake, which is then distributed into the cylinders. So how about on these newer electronic throttle bodies? Well, these type of throttle bodies, instead of using an idle air control valve to regulate the airflow at idle, they've gotten rid of them. So the computer can electronically control this throttle plate's angle to adjust the airflow at idle. So it'll open this plate a little more on cold starts, and once it's warmed up, we'll close the plate a little more, but will never fully close, unlike the mechanical throttle bodies that are controlled by a throttle cable. So now that we know how they work, what are the symptoms when an idle air control valve isn't working as it should? Well, an idle air control valve that is stuck open, as we mentioned earlier, it can cause a surging idle, which is a condition when your engine will rev up and down as your vehicle is on and idling, or at a stoplight. To more severe situations where your car will not even want to idle, it'll shut off at stoplights or will be hard to start. Now this valve can also stick closed, and in this situation your car will not want to start due to the fact that the valve isn't allowing air to enter the engine during cold starts, so it's just throwing fuel into it, yet no air to keep it running. Or maybe it may start, but feels weak and runs rough at idle, so you help it stay running by revving the engine, opening the throttle body valve to allow air through. So what can you do if you experience these issues? Well, first thing you always want to do is check your coolant level. since this valve uses coolant to circulate through the valve to open it and close it. Even on these others, the computer still uses the coolant temperature to help it figure out when to open it and close it as well. Once you verify that the coolant level is okay, we can try cleaning them using throttle body cleaner, a brush, or a clean towel. When cleaning them, all we're trying to do is clean anything that may obstruct or prevent them from fully closing or opening. Like on this Toyota valve, we'll want to clean the coolant passages and remove any gunk that may be stuck inside, preventing proper coolant flow. Followed by cleaning any ports where the airflow passes through to make sure they have proper flow and allow the necessary amount of air through. You also want to make sure the passages on the throttle body are clean, since they can also get full of gunk and obstruct airflow. This Honda one, we can check its operation using a 9-volt battery and some jumper wires. When doing this, you want to avoid the wires or the prongs touching each other, or it could damage the valve or the battery. But this is why I find it safer to use a 9-volt battery. To get started, we'll be connecting the red jumper that will connect to the positive to the middle of the 3 prongs, which will be the common, and our negative will go to either remaining 2 prongs. To one side it should close the valve, which I believe is this one. Which it's doing there, but you can't really tell. Let's rotate it to see if you could get a better view. And it does look like this one's closing the valve. Now if we swap the negative to the other prong, it should open the valve. Which it does. So that tells us that this valve is operating properly. We can also do a resistance test to check the coil driver circuit. Using our multimeter, we'll set it to read resistance, which is the little omega symbol on the dial. For our resistance check, we check our first driver by connecting one lead to prong number 1 and the other lead to the middle prong. It doesn't matter which color test lead goes where, it won't affect it. And a good reading should be within 16 to 28 ohms, which our reading of 18.6 ohms falls within good specs, so this one is good. To check our second driver, we connect the test leads, one to the prong in the middle and the other lead to prong number 3. Once again, we want the resistance between 16 to 28 ohms, giving us 18.6, another good reading. With these results, we can confirm that this idle air control valve is good. On this 4-wire idle air control valve, this one we can check the driver coils by checking resistance between these first 2 prongs. And we want these to fall within specs, which are between 40 and 80 ohms. And we got 49, which is a good reading. Now to test prongs 3 and 4, and we want these to give us a similar resistance reading, which are between 40 and 80 ohms. And we're getting 49, which is a good reading. Well, that'll pretty much do it for this video. I hope you found it helpful or informative. If so, please click that thumbs up button to support my video and my channel. And please subscribe if you haven't done so.